Thanks for watching my video. Today I'm going to discuss one theorem in continuity and differentiability. Okay? In the theorem stated that if a function f is differentiable, okay, the function f is already differentiable, okay, at a point a, then it is also continuous at that point. That means at that point mean a, at point a. Okay, this means that the function f is already differentiable, okay, at point a. That means we are going to prove that uh, it is also continuous at point A. Okay. Now first of all, we are going to discuss what is continuous function. Okay. A function is said to be a continuous. Okay. Let's say a function y is equal to f of x is said to be continuous function if number one, f of a exists. Okay. If f of a exists, that means if f of a is finite number, and number two condition is that if limit x tends to a, f of x exists. Okay. And the third condition is that if limit x tends to a, f of x is equal to f of a. Okay. If a function follow this three properties, okay, so we can say that this is differentiable at x equal to point a. Okay. And when is a function said to be differentiable? If right hand differentiable and left hand differentiable are same. Okay. At that place we can say it is differentiable. A function is said to be differentiable. So we are going to prove this one. Now since f is differentiable, okay, the question said that f is already differentiable at x equal to a. Okay, so from definition, f does x, which is derivative. Okay, derivative of, since we are going to find for point a, this is point a. Okay, it will be limit h tends to 0, f of a plus h minus f of a over what, h. Okay, this is the definition of differentiation. So okay, such that, and in here, okay, I can rewrite this as what, I can rewrite this one as f thus a is equal to limit x tends to a. So now here x tends to a, f of x minus f of a over x minus a. Okay, I can rewrite this one as like this, and here says that x is not equal to a, x should not be equal to a. Okay, so a function is said to be continuous, okay, if satisfied these three conditions. Okay, and out of this we are going to show here is that number 3, this 3, limit x tends to a, f of x is equal to f of a. We are going to show this one. Okay, now since we are going to find f of x minus f of a, so let's take f of x minus f of a. Okay, which is equal to what, f of x minus f of a over x minus a. Since I divide here, so I'm going to multiply here again. Okay, such that x is not equal to a. This condition should be satisfied. Okay, now from this I'm going to take the limit now. Limit x tends to a. Okay, f of x minus f of a, which is limit x tends to a, f of x minus f of a over x minus a, and applying properties of limit. Okay, in the second step let's apply it. Okay, now from properties of limit, applying the properties of limit here, limit x tends to a, f of x minus limit x tends to a, f of a, which is equal to limit x tends to a, f of x minus f of a over x minus a into limit x tends to a x minus a. Okay, this is properties of limit, which is equal to limit x tends to a f of x minus limit x tends to a f of a, which is equal to, and this is what is this? This is same as where this one is, am I right? So I can replace it like this, and limit, if you put x equal to a here, that means 0, you will get 0. Okay, 0 into something means 0. So limit x tends to a f of x, I'm going to transfer here, so positive, and limit x tends to a f of a will be what can we get here? We will get f of a. Okay, because example limit x tends to, let's say 0. Okay, 1 is what? Just 1. Okay, same thing like this, because here does not contain x, here also does not contain x, so it's same thing as, so this means it satisfy what? Condition 4. Okay, condition 3. That means if a function is differentiable at point a, then it is also continuous. So this shows that it is continuous at that point also.